children, welcome to our Gedara program. Nice to meet you again. Hope you are doing fine. Today I am going to talk about the part 2 of chords of the circle. You have joined with me the previous lesson part 1 chords of the circle. So we have discussed the theorem under that part. Today I am going to discuss part 2. Under the part 2 I hope to discuss converse of the theorem. So I have prepared few sums. So under this lesson, when you are studying this lesson, what are the things you can gain? Solve the problems by using the theorem that the perpendicular drawn from the center of a circle to a chord bisect the chord. Previously we have, in previous lesson, in previous part we have discussed, we have done the sum. So from that we got the outcome. What's that? Solve problems by using the theorem that the straight line joining the midpoint of a chord of a circle to the center is perpendicular to the chord. So we have done it under the part 1. Today we will able to get that solve the problems by using the theorem that the perpendicular drawn from the center of a circle to a chord bisect the chord. So this is the converse of the theorem actually. We are trying to apply the converse of the theorem and we will solve the sums related to that one. Here, before telling the converse of the theorem, before studying the converse of the theorem, I am going to revise what we have learned under the part 1. So under the part 1 you learned the theorem. Okay, I am going to revise that. I think you remember that. First of all, I want to ask one thing from you. I gave homework to do 27.1 and 27.2. I think you have done. They are very easy. Okay, I think you have done them. Today, we have to do the remaining exercises. Then, before doing them, we have to do the lesson. No? Okay. To revise your knowledge from the previous part to gain, here the theorem we learn, the straight line joining the center of the circle to the midpoint of a chord is perpendicular to the chord. So you learn that thing under the part 1. Here using the diagram also I explain. Here you can see the diagram. So PQ is a chord of the circle with the center O, and this is the PQ chord, and we can name the midpoint of the chord as R. Then when the midpoint of the chord as R, that means by the point R, bisect the PQ chord. That means bisecting the PQ chord means it's separating equally. It's separating equally. Okay. Then we are going to join the center and the midpoint of the chord. So by joining the center and the midpoint of the chord, it will be perpendicular to the chord. That is the theorem. So OR is perpendicular to the chord PQ. So in this diagram we have taken PQ as the chord now. We have taken R as the midpoint of the chord. And in here we have joined center and the midpoint of the circle. So that here midpoint of the chord and the center we have joined, that OR line is perpendicular to the chord. So that is the theorem we learn under the part 1. Again I am saying the theorem. The straight line joining the center of the circle to the midpoint of the chord is perpendicular to the chord. Can you tell it with me? Theorem. The straight line joining the center of the circle to the midpoint of a chord is perpendicular to the chord. Here we have to move to the converse of the theorem. Today we are going to learn the converse of the theorem. The converse of the theorem. What's that? Here we can see the converse of the theorem. The perpendicular drawn from the center of a circle to a chord bisect the chord. Again, converse of the theorem. The perpendicular drawn from the center of a circle to a chord bisect the chord. Using a diagram also, I can explain that. Here we know O is the center of the circle and PQ is the chord of this circle. And here we join OR and PQ perpendicularly. In the diagram, OR and PQ join perpendicularly. So, according to the converse of the theorem, what can you say? we can say R is the midpoint of the chord PQ. R is the midpoint of the chord PQ. That means PR is equals to RQ. PR is equals to RQ. That is the thing we expressing from the converse of the theorem. Then we can do some examples to emphasize that converse of the theorem. So, you can do the examples with me. Then you can get the idea about the converse of the theorem and you can practice it well. Okay, you try to do with me. Here I will give one example. This is the example. You can see it clearly. You have to find the perimeter of the triangle OCB. First of all, you have to identify what are the given things. In this circle, center is O and you can see a chord. What is the chord? AB. AB is the chord of this circle. Then you can see OA and OB ready and you can see OC has already joined, but OC line is joined to the AB chord perpendicularly. That's very special. So, that is the situation we can apply the theorem. We can apply the theorem in there. Okay, because we can see the center and the point on the chord has already joined. No? That line is perpendicularly joined. So, according to the converse of the theorem, we can say C must be the midpoint of the chord. So, by looking at the sum, we can get that idea. Before doing the sum, we can get that idea. Then, we have to find the perimeter of the triangle OCB. Look at the triangle OCB. So, when you are finding the perimeter, what do you mean perimeter? Perimeter means length around a figure. Total length around a figure is calling as the perimeter. Look at this triangle OCB. So, when you are taking the perimeter of the triangle OCB, we have to add up the length of all three sides of this triangle. What are the three sides of this triangle? OB, OC and CB. You can see it clearly. But when you take the perimeter, you should know all the length of these, you should know the length of all three sides of this triangle. But can you see the length, all the measurements, length of all three sides of this triangle? OC, BC and OB. Can you see that? You can see only length of OC line. Length of OC line. But still you don't know the length of other two sides. What are the other two sides of this triangle? OB and BC. We know the length of the OC side only. We have to find that. You think, how do we find the length of other two sides? In that case, we have recognized, here we have identified, we can apply the converse of the theorem for this. Because we can see a perpendicular drawn from the center to the given chord. According to that, we can say C is the midpoint of this AB chord. I am going to do that sum now. Because C is the midpoint of the chord, then we can consider AC and CB as equal. If AB is 16 centimeter, AC is 8 centimeter and CB also 8 centimeter. So, we are going to do that. You can do with me now. Here we know OC is perpendicular to AB. If OC is perpendicular to AB, what is the conclusion can be taken? That is, C will be the midpoint of the chord. I told you earlier. Previously I told you. But here also I am going to tell that C is the midpoint of the chord AB. Then we can say AC equals to CB equals to 8 centimeter. Why it is 8 centimeter? Because AB line segment mean actually AB is the chord. So, chord AB is 16 centimeter and half of that is 8 centimeter. Then you have to AC and BC length. We can mark like that. Then you should find the OB length. Before that, how do we find that OB length? How do we find the OB length? Here in the OBC triangle, that is a right angle triangle. That is a right angle triangle. In here, we know two sides, OC and BC. So, when you are taking the right angle triangle, if you know the length of two sides of that triangle, how do we find the other side? How do we find the length of the other side? You remember relationship you learned in earlier grades. In grade 9, you have learned that. You remember that's Pythagoras relationship. You can apply that to find the remaining side of the right angle triangle if you know two sides of that. Here I am going to explain it again. So, you have the triangle OCB, that is right angle triangle, and you know the length of two sides, one is OC and other one is BC. Then you can find the length of OB side. You can apply the Pythagoras theorem. Pythagoras theorem. Here, what is the hypotenuse here? OB. And what are the other adjacent sides? OC and CB. So, we can apply the Pythagoras theorem. OB squared is equals OC squared plus BC squared. Then we should substitute the values. Do you know the OB value? Do you know the OB value? You don't know. We are going to find that. Okay, then OC is 6 centimeter. We can substitute that. We don't know OB, we know OC and we know BC. So, OB, we are going to find OB and OC is 6 centimeter and BC is 8 centimeter. Then we can find OB, we can substitute that. Here I have substituted it. OB squared equals 6 squared plus 8 squared. Then 6 squared, what's the value of 6 squared? It is 36. And 8 squared, it is 64. Then we can add up them. So, then you have OB squared is equals 100. OB squared is equals 100, but we should know OB. OB squared, from OB squared, how do we take the OB? By considering the square root of the 100, we can get OB. OB is equals 10 centimeter. We found that value OB. Now we know the length of the three sides of this triangle OBC. What are the sides? OB, OC, BC. What's the length of OB side? We found that 10 centimeter. What's the length of OC side? It's 6 centimeter. What's the length of BC side? It's 8 centimeter. We should find the perimeter of this triangle. To find the perimeter of this triangle, we should add up these three measurements that you obtain to length of these three sides. So, perimeter means length around the figure. Now, we have to add up the length of all these three sides to get the perimeter of the triangle OBC. Let's add them. Then we can find the perimeter of the triangle OCB. So, 10 plus 6 plus 8. 10 is OB. OC is 6 centimeter and 8 is BC length. Then we get 24 centimeter. So, we got the answer. 24 centimeter, what's that? Perimeter of the triangle OCB. We found the perimeter of the triangle given here as the 24 centimeter. Okay, I think you understood that well. So, in here we have applied the converse of the theorem. So, how do we apply the converse of the theorem? We could see a line join the chord and the center perpendicularly. In that case, we can say C as the midpoint of the chord. It's the important part of this sum. Then we can do another example. So, here I have taken, you should take your textbook and turn the page 110. You can see the exercise 27.3. I have taken the fifth sum. You have to see that sum, the diagram. Then I am going to read the sum. Look at the diagram and then you have to read the sum. PQ, RS are two parallel chords. PQ and RS are two parallel chords of the circle with center O as shown in the figure. So, you can see the figure clearly. PQ and S are as chords, but specially these two chords are parallel. The radius of the circle is 10 centimeter. The radius of the circle is 10 centimeter. If PQ is 12 centimeter and SR is 16 centimeter, they are the chords here, okay? They are the chords here, PQ and SR. PQ is 12 centimeter and SR is 16 centimeter. Find the distance between two chords. Distance between two chords. Actually, these two chords are parallel. So, distance means you have to consider the perpendicular distance. So, like this. So, you have to consider that perpendicular distance. That is the thing they asked to find the distance between chords. These two chords PQ and RS. Then we try to find that distance. Do you have an idea to find that? Then you can think that how do we do that? Here I think it's better to do one construction, otherwise you can't do that. You should do one construction, then you can get that distance, the distance between two parallel lines. To do that we are going to do a construction. How do we do that construction? Let's think. So, here we know what are the radii of these two, what are the radius of this circle, and we have to join line to represent the radius, and we should do one construction to do this one. Let's see here. So, I have marked the given data. PQ and SR are parallel lines. PQ is 12 centimeter long chord and SR is 16 centimeter long chord. Then I am going to join OQ and OR. Another one. So, joining OQ and OR, it's okay, and I am going to draw a perpendicular to PQ from the center. So, I am going to draw the perpendicular from the center to PQ. So, while I am drawing the perpendicular to the chord PQ, it will be a perpendicular to the chord SR. Why? I am going to draw the perpendicular to PQ from the center O. While I am drawing the perpendicular to the chord PQ, it will be automatically a perpendicular to the chord SR. Why? PQ and SR chords are parallel to each other. That's why I can say the perpendicular drawn to the PQ is already perpendicular to the SR. So, here we should do that construction. Let's see, here I am joining OQ and OR. They are the radii here. Okay, OQ is also representing the radius of this circle. OR is also representing the radius of this circle. And I am going to do my construction here. What's the construction? Drawing a perpendicular to the PQ. Here no need to use the compass to construct that. Just you draw a line and you mark that as the perpendicularly by putting the right angle here. So, that is the perpendicular. To show that we can put the right angles like this. So, then according to the construction, our target is finding the AB distance. So, I marked this AB distance. I marked 2 points as A and B to represent that distance AB. So, we should find that distance. So, how do we find that? You look at the line OA, If you know the length of OA and if you know the length of OB, to get the distance between PQ and SR, I mark it as AB. We can get AB distance. How do we take the AB distance? If you know the OA length and if you know the OB length, then you can take AB length. How do we take AB length? By subtracting OB length from OA length, you can get AB length. Let's try to find that OA length and OB length. How do we find that OA length and OB length? That's the problem. So, if you know those two, you can find that AB distance. Let's see that. How do we find that? Look at the diagram and you can see OAQ right angle triangle, right angle triangle, and you can see OBR right angle triangle. So if you have a right angle triangle, if you know the two sides of that, you can find other sides using the Pythagoras theorem. Let's see how do we do that. Here you can see it clearly. We know OB is perpendicular to SR. Why? We got that from the construction. OB is perpendicular to SR. Because of that, we can apply the theorem, converse of the theorem. So, by the converse of the theorem, we can say B is the midpoint of the SR chord. Why? OB is perpendicular to SR. Then we know B is the midpoint of the SR chord. Therefore, we can say SB is equals to BR. Here OA is perpendicular to PQ. That was given. So, given mean I have constructed that. According to the converse of the theorem, we can say A is the midpoint of the chord PQ. That means we can say PA is equals to AQ. So, we know PQ chord length is 12 centimeter. Therefore, PA and AQ should be equals to 6 centimeter. We should consider the half of that. So, we have to, in here we have applied the converse of the theorem. What's the converse of the theorem? A perpendicular drawn from the center of the circle to a chord is bisect the chord. So, by using that we have got the length of PA, AQ, SB and BR. Let's see how do we do other part of this and how do we continue that. Here I have marked in the diagram SB as 8 and BR as 8. Okay, here we know the radius of this one. Radius of this circle is 10 centimeter. So, we know here OQ is the radius of this circle, OR is the radius of this circle. So, I can mark them like 10 centimeter and 10 centimeter. So, we are going to find the length of OA and length of OB. To find that, we will use this right angle triangle. Using the right angle triangle, how do we find the length of the sides? Using the Pythagoras theorem. Look at this right angle triangle OAQ. In this right angle triangle, we know two sides of that. So, we should know other side. To find that side, we use Pythagoras theorem. Using the Pythagoras theorem, we can find the AO side length. So, what is the hypotenuse of this one? Hypotenuse of this triangle is OQ. It is opposite to the right angle. OQ squared is equals AO squared plus AQ squared. Then we have to substitute the values given here. OQ is 10, AO we don't know and AQ is 6. Then we have to simplify that. 10 squared is 100, AO squared, 6 squared is 36. Then we should find AO squared. AO squared is equal 64. If AO squared is equal 64, we can get AO. AO is square root 64, that is 8 centimeter. So, we found AO. But still we don't know OB. If you know OB and OA both, we can find AB. Okay, here now I am trying to find OB length. How do we find the OB length? So, in here also we have to use the right angle triangle. So, we can consider the right angle triangle OBR. The right angle triangle OBR. So, in here also we know length of two sides. What are the sides? OR and BR. So, we should find OB. Same thing we have to do. We have to apply the Pythagoras theorem to find the OB length. Okay, according to this triangle, what is the relationship? OR is the hypotenuse, OR squared equals OB squared plus BR squared. Then you should substitute the values. OR is 10 and BO we don't know, and BR is 8. So, we have to substitute that. Then we should solve it and we get BO squared is equals to 36. Then we can find BO. BO is equals to square root 36. It is 6 centimeter. Okay, we have found two values. What are the two values? OA length and OB length. We have found OA length and OB length. Target is finding AB length. That is the distance between two parallel lines. We have found OA length and OB length. We should find AB length. AB length is the distance between two parallel lines. Two parallel lines mean the chord SR and PQ. So, we are going to find that AB length using OA length and OB length. Let us see that. Here, the distance between two chords is AB, and we can find that AB is equals to OA minus BO, or AO minus BO. So, we know what is AO. AO is 8, BO is 6. So, what is the distance between two chords? That is 2 cm. AB distance means the distance between two parallel chords. That is 2 cm. So, we have found that. That is very easy. In here also we have applied the converse of the theorem. Okay, children. Let us do another sum. Let us do another sum. Here. So, this sum I have collected from your textbook. This is coming under the page number 113. So, this sum I have taken from the miscellaneous exercise, 8th sum. So, you may think this sum little bit hard. It is not like that. So, you read the sum carefully and try to do that. First, you read the sum several times, one time and second time, and you highlighted the things that you should remember. Here, look at this one, PQ and RS are two chords of the circle with center O. The perpendiculars drawn from O to PQ and RS are OX and OY respectively. Show that PQ squared minus RS squared is equals 4OY squared minus 4OX squared. In here, this sum you have two chords, and we can see two perpendiculars drawn from the center to the given two chords. So, there is a relationship. There is a relationship to prove that. Look at that relationship. PQ squared minus RS squared equals 4OY squared minus 4OX squared. We have to show that. PQ, look at that PQ. PQ is the chord. RS is also the chord. And OY is the line drawn from the center to the chord perpendicularly. OX, what is OX? OX is also the line drawn from the center to the chord perpendicularly. So, this relationship is the connection between the length of the chords and the length of the perpendiculars drawn from the center to the chord. So, we have to build up this relationship. Let us see how do we do that. So, we have to consider these chords. So, we have to apply the converse of the theorem. Let us see whether it can be applied or not. Here we can see a perpendicular drawn from the center to the chord. In that situation, you can apply the converse of the theorem. Converse of the theorem. So, in there we can say when we are drawing a perpendicular from the center to the chord, by that line bisect the chord, bisect the chord. In here we know two chords. In here we can see two chords, and to those two chords they have drawn two perpendiculars from the center. They have met at the point x and y. So, OX and OY, OX and OY, by the OX and OY, bisect the chord PQ by the point x, bisect the chord RS by bisect the chord RS by the point y. So, in there we can apply the converse of the theorem. So, let us see how it is happening again. Then to find this relationship, to show this relationship, we have to join OQ and OS. OQ and OS, they are the radii of this circle. O is the center and we join OQ and OS. So, we have to join them. So, we are joining them, then we get right angle triangles. What are the right angle triangles? OXQ and OYS. So, here we are going to build up that relationship. In that relationship, you can see that length of the sides has already squared. So, length of the sides already squared. So, we have to consider the Pythagoras theorem. In the Pythagoras theorem, you know, when we are taking the relationship of the three sides of the right angle triangle, we get the square of them. We have to get the square of the side length. So, in here we have to think about that Pythagoras theorem. According to the Pythagoras theorem, we can build up that relationship, the given thing that we have to prove. Let us see. So, after joining OQ and OS, let us try to build up a relationship. In here, using the Pythagoras theorem for the triangle OXQ, we can make a relationship. What is that? O cube squared is equals OX squared plus X cube squared. O cube squared is equals, O cube is the hypotenuse, that is the radius of this circle, O cube is the radius of this circle. So, O cube squared is equals OX squared plus X cube squared. Then you can use the Pythagoras Pythagoras theorem again for the triangle OYS. For the triangle OYS also we can apply the Pythagoras theorem. In here also you have to consider the hypotenuse, that is OS. OS squared is equals OY squared plus YS squared. Here you have already built up now two equations using the Pythagoras relationship, Pythagoras theorem. Then O cube squared equals OX squared plus X cube squared and OS squared equals OY squared plus YS squared. What can you say about this OQ and OS? Let us see it later. So, O cube squared is equals OX squared plus X cube squared. So, I can name that relationship as, that is also an equation, no? I name it as 1. And the next one, OS squared equals OY squared plus YS squared. I can name it as 2. Here I am going to make some relationship with using these two equations. Okay, here OQ and OS, what can you say about them? They are the radii of this circle. So, if they are square in that square OQ is the radius and square of OQ, and OS is the radius, OS squared. So, they are radii, OQ and OS are radii. Then if they make squared also, we can say they are equals. So, here we have to build up, we have to make a relationship with equation number 1 and equation number 2, they are equals, because OQ and OS as radii, they are equals. Then we can build up the new relationship. What is that? Using the right hand side of these two equations. What is that? OX squared plus X cube squared equals OY squared plus YS squared. So, this is the new relationship. But when we are doing that, you have to pay attention the thing you have to show. Here we got OX squared plus X cube squared equals OY squared plus YS squared. But the given thing, P cube squared minus RS squared equals 4OY squared minus 4OX squared. So, from this relationship, the newly got relationship, you have to consider that. From that we try to take the given thing. So, how do we do that? Here I have written them together. So, we got OX squared plus X cube squared equals OY squared plus YS squared. In here, how do we do that? In the given one, in the sum we should prove, in this relationship in the sum we can see OX squared. In our relationship also we can see OX squared and OY squared. So, X cube and YS, we have to consider those two. We try to remove that X cube and YS with using PQ and RS. Let us see. So, we have built up a relationship with X cube. When we are doing this sum, beginning of this sum, we have built up a relationship with X cube. X cube is equals to half of PQ. We have built up that. And we have built up YS. YS is equals to half of RS. We have built up beginning of the sum. So, we can substitute those things to this relationship. So, how it is coming? OX squared plus, instead of X cube squared, we can substitute PQ divide by 2, half of PQ, and we should put square root of that, half of PQ, and get the square root of that equals OY squared plus RS over 2. That means half of RS. Half of RS, get the square root of that. How do we solve this? So, we have to consider this PQ over 2 squared. PQ over 2 squared. So, how do we solve that? With this square, this power 2 is coming to PQ and to both. Power 2 is coming. So, we have to solve that. OX squared plus PQ squared over. So, 2 to the power 2 will come now. Then 2 to the power 2 makes 4 equals OY squared. OY squared plus RS squared and 2 to the power 2 makes 4. So, this is the newly one, new relationship we got. What's that? OX squared plus PQ squared over 4 equals OY squared plus RS squared over 4. Look at that one, but it's still not it's coming. So, we have a denominator 4. We have a denominator 4. So, we should remove that. We should remove that denominator 4. There are 2 terms coming with the denominator 4. How do we remove that denominator 4? So, we can multiply each term by 4 to remove that. Each and every term, there are 4 terms in this equation. So, we should remove that denominator 4 by multiplying 4 each and every term. Let's multiply that. Let's multiply that. Here OX squared is multiplying by 4, PQ squared over 4 is multiplying by 4, OY squared is multiplying by 4, RS squared over 4 is multiplying by 4. Here, when we are multiplying these each and every term by 4, our target is removing the denominator 4. Okay, then what will come? When we multiply that, we get 4OX squared, 4OX squared plus we can cut that denominator 4 with the multiple of 4 in the PQ squared over 4. Here we multiplied that PQ squared over 4 by 4, no? Then we can cut that. Our target is that, removing the denominator 4. It's cutting. And next one, PQ squared equals to 4OY squared. So, next one we can cut denominator and the 4, then we get RS squared. So, we got this 4OX squared plus PQ squared equals 4OY squared plus RS squared. Look at the given thing that we have to show. Still we didn't get that, but you can see the terms are same. We can see OX squared, we can see PQ squared in the both one, the sum and the relationship we obtain up to here, OY squared and RS squared. But we have to change these terms. We have to change these terms to get the correct one. Let's see how it is coming. I have removed that OX squared from the left hand side to the right hand side. I have removed RS squared from the right hand side to the left hand side. Then we got PQ squared minus RS squared equals 4OY squared minus 4OX squared. Okay children, I think you understood that. So, we have applied the converse of the theorem. Then you have to practice more and more sums to do emphasize this theorem further. So, because you know for your O-level paper, for the second part you have 3 geometry sums. You have 3 geometry sums. One sum is coming from circle theorems. 3 geometry sums mean here I have considered the construction sum also. And the first paper, for the first paper under the geometry theme, including the first 25 questions, you have 8 sums from the geometry. You have 8 sums. You may face to 8 geometry sums. So, 1 or 2 sums coming from the circle geometry. So, you have to practice this. In this lesson, we studied two theorems now, and later on you will study another 3 theorems in the grade 10. Then when you go to the grade 11, you will be studied another circle theorems under the cyclic quadrilaterals and tangents. Here, so I want to show something. So, there are some past paper sums. So, I have selected 2017 and 2016. So, there are 2 sums I have got from those 2 years. So, those sums taken from Chords of the circle lesson. Look at that. So, I am going to discuss with you those sums. Here, this is the sum I have collected from collected from the 2017 paper. So, this is the first part paper sum. So, the 17th sum, you can see that. So, this sum taken from the chords of the circle lesson. In the figure, xy is a chord of a circle with the center O. The point Z lies on xy. Xy is the chord, okay, xy. As shown in the figure, for each statement given below, if it is correct, mark the tick, and if it is incorrect, mark the cross in the box in front of it. So, you can see a box. What are the things in the box here? Xy is equals to xz. Another one, xoy, the angle xoy is equals twice of angle xoz. So, we have to check whether they are correct or not. So, this is the diagram you have. How do we check that? Xy is equals 2 times of xz. So, by looking at the sum, you can understand. If you know the theorem, if you know the converse of the theorem, you can understand. But here I am going to explain it further. Here by this is the first paper sum, no need to do a lot of workings. By looking at the sum, you can put tick or cross. But here I am going to explain that, because from this sum you have 2 marks only. Just look at the sum and you can mark as correct or wrong. But I am going to explain you. Look at that. Xy is a chord. Xy is the chord that was given. And what else you have? You know OZ is perpendicular to xy. That is also given. OZ is perpendicular to xy. Because of that we can say xz is equals to zy. Xz is equals to zy. Why? A perpendicular drawn from the center of the circle to a chord is bisect the chord. So, using that you can tell, you can make a relationship. What's that? Here you know xz is equals zy, then you can say xz plus zy is equals to xy. Xz plus zy equals to xy. Then you know xz is equals to zy. Xz is equals to zy. Then instead of zy I can put xz. Okay, instead of because they are equals, no, instead of xz, instead of zy I can put xz. Then xz plus xz makes 2xz. 2xz. 2xz equals xy. 2xz equals xy. Okay. Then second part of that table, xoy is equals to xoz. You have to check whether it's correct or wrong. Xoy, the angle xoy is equals to 2 times of xoz. Let's see whether it's correct or wrong. To do that, I will take the congruency. So, I am going to congruent 2 triangles in this circle. 2 triangles. What are the 2 triangles? To make the 2 triangles, I have joined OX and OY line. OX and OY line. So, then I can congruent the 2 triangles OXZ and OYZ. Let's see whether we can congruent or not. So, to congruent 2 triangle, you know it should be equals 3 elements of 2 triangles. So, here what are the elements can be seen? To make them as equals, to say them as equals in these 2 triangles OXZ and OYZ. We know XZ is equals to ZY, XO is equals to OY. XO is equals to OY, those are the radii of this circle, and OZ is equals to OZ, that is the common side. Therefore, we can say OZX and OZY, they are congruent triangles. They are congruent triangles under the case of SSS, side, side, side. So, we have congruent those 2 triangles. If these 2 triangles are congruent, what can you say? Remaining corresponding elements of congruent triangles are equals. What are the remaining corresponding elements? They are, then we have to consider here one pair. What's that? The angle XOZ, the angle XOZ and the angle YOZ, they are equals. They are equals to each other. Why? Remaining corresponding elements of congruent triangle. So, if XOZ equals to YOZ, then you have to consider the angle. What's that? XOZ equals to YOZ, then adding those two angles you make XOY. When adding those two angles, I mean XOZ and YOZ, when adding those two we can see the angle XOY, that's big angle XOY. So then we can consider, instead of YOZ we can consider XOZ, because previously we have found XOZ and YOZ as equals. Then we can say 2XOZ is equals to XOY. The angle, twice of the angle XOZ is equals to the angle XOY. Then we have proven early 2 times of XZ is equals to XY, and according to the table, what can you say about the both statement? They are correct. So this is first paper sum. No need to do like this, just I explain that, but by looking at the diagram you can understand it if you know the theorem well. Okay. So here I am going to do another sum that's coming for the 2016 paper. Here the radius of the circle with the center O in the figure is 10 centimeter. Find the length of the chord AB using the given information. Look at that. AB is the chord. We can see a line drawn from the center to the chord perpendicularly. The length of that line is 8 centimeter. We have to find the length of the chord AB. But radius was given. Radius is 10 centimeter. So here we can apply the converse of the theorem. When we draw a perpendicular from the center to the chord will be bisected. That's the converse of the theorem. We have to find the length of AB. Here I have joined the radius OA and OB, because we know the length of the radius, no, they are 10 centimeter. Here also we have right angle triangle. We have right angle triangle. In this right angle triangle we know two sides length. Let's see how do we do that further. So we know OX is perpendicular to AB, I told you, and AX is equal to XB because of X is the midpoint of the chord. A perpendicular drawn from the center of the circle to a chord is bisect the chord. So using that we can say that. Okay, then we can find the AB length of the AB chord by considering XB length. How do we do that? Using the Pythagoras theorem always. We get the help of the Pythagoras theorem. Look at that, because of this is right angle triangle, now then we can find the length of AX. How do we find the length of AX? Here we can find the AX length using the Pythagoras theorem. So OA squared is equals OX squared plus AX squared. So we know OA squared, that is 10 squared, OX squared, that is 8 squared, and we can find AX. So 10 squared is 100, 8 squared is 64, then we can find AX squared. AX squared is equals 36. So we can find AX. AX is equal 6 centimeter by taking the square root of 36. So if you know AX, you know XB. Why AX and XB equals? Then we can make a relationship. AX plus XB makes AB chord. So AX and XB equals now. Then we can get AB length by taking the twice of XB or AX length. That is 12 centimeter. AB length is 12 centimeter. That is the length of the chord AB. Okay. Now I think you have understood the sums I told, I explained you. So using these two theorems in the previously under the part 1 we have discussed the theorem, under the part 2 we have discussed the converse of the theorem. So I am going to revise the thing you learned. Here the theorem, the straight line joining the center of the circle to the midpoint of a chord is perpendicular to the chord. What is the converse of the theorem? The perpendicular drawn from the center of a circle to a chord bisect the chord. So using a diagram also we can understand that. PQ is a chord of the circle with the center O. If PR equals to QR, therefore we can say OR is perpendicular to PQ. And the converse of the theorem also I can show using a diagram. What's that? PQ is the chord of the circle with the center O. If OR is drawn perpendicular to PQ, therefore we can say R is the midpoint of PQ chord. Then PR is equals to RQ. then you have to do some homework. What are the homework? I think you have only 3 exercises remaining, 27.3 and 27.4, and we remain the miscellaneous exercise. You have to do those things as the homework, and you should do extra sums from the other activity books, and you can do more and more sum to practice well. So, we have done 2 parts under the chords of the circle. So, you have to practice lot of sums, and you have to repeat the sums, repeat to doing the sums several times, then you may practice the theorem and the converse of the theorem. Okay children, you have to do your homework and you have to practice lot of things, lot of sums. Okay. Now, I am going to wind up my lesson. I will see you soon with next lesson. Have a nice day.